Hi girls. Good afternoon or good morning or whenever you're getting this. I'm just going to do a quick another mind map. I got a little bit of feedback from a couple of people yesterday and they seem to think that the mind map on moles was useful. So this one is going to be based on gas laws. Okay, so what we're looking at today is gas laws. Always a good idea to write down the topic first, isn't it? Yeah. So this section brings us into, there's a few things. There's the things that we need to know about gases, and then ultimately it leads us into understanding a little bit about moles. So there are a number of basically concepts or laws that we need to understand about gases, first of all. The first one is how gases move, and that's a process known as diffusion. Now you'll know what that is, because that's something you learned for junior cert, when things move from a high concentration to a low concentration. Okay, now again, I'm just making a mind map, so I'm not writing everything out fully. I'm just going over the concepts in my head and I know what they mean. Okay, another concept that's important is the ideal gas, the concept of an ideal gas and what that is. And that means that they obey all the laws of kinetic theory. Okay, again, these are important definitions that you need to know completely and very accurately, but I'm just scribbling them down for the purposes of what we're doing today. Right, now, once we've established that we know what an ideal gas is and that we know what diffusion is, there are a number of laws that are really important. And the first one to remember is Boyle's law. And Boyle's law tells us that the volume of a gas is indirectly proportional to its pressure. And we can write this in a kind of a mathematical concept, if you like this, which is V equals 1 over P. In other words, the bigger this gets, the volume, the smaller this gets, the pressure. And again, this is kind of a reasonably common sense concept to us in terms of using a pump for your bike, right? You squeeze the pump down, you're reducing the volume, you're increasing the pressure. So it's fairly straightforward. No one's really, gobsmacked by that idea. The next concept or law that we need to know is Charles's law. And Charles's law links the pressure. Sorry, it doesn't. It links the temperature to the volume. So at constant pressure, the volume is directly proportional to the temperature. And again, we have a mathematical way of writing that. We say V equals kT. K is the constant, V is the volume, T is the temperature. In other words, the greater the temperature, the greater the volume. Another way of saying that gases expand when they get warmer, which again, you're familiar with already from lots of different things. Okay, so sometimes what we do is we combine all this in what's called the combined gas law. And the combined gas law basically puts these two ideas together. And we sometimes write it like this. P1 V1 over T1 equals P2 V2 over T2. And that's basically just a mathematical way of combining, I'm just trying to turn this around so you can see it clearly, combining Boyle's law and Charles' law together. That if we change the pressure and the volume of a gas, we can figure out its temperature. Now this, to be honest, doesn't come up very often in exams for the simple reason that it's actually quite straightforward. They have to give you a lot of information. Remember, in an exam question, there'd only be one unknown, so they'd have to give you, essentially 5 pieces of information. So it doesn't come up very often. I could find one from an ordinary level paper in 2009. I think it's question 10. I can't remember now. I know it's part B, part 2 or something like that. But it doesn't come up very often, right? Nonetheless, it's important to just recall. This is also in your log tables if you were to need it, okay? Right, now, let's go back to the laws. There are 2 other laws that are really important. You must know Boyle's law and you must know Charles' law. Obviously, for the sake of this mind map and to, make things a little shorter, I've written their mathematical representations. You need to know them in terms of words as well. So that's definitely something you should practice, and in your own time you can practice writing them out. There are 2 other laws you need to be familiar with. One is, we'll do Gay-Lussac first. So Gay-Lussac's law. And Gay-Lussac basically said that gases react in ratios of small whole numbers. Okay? That's basically what molar ratio is. So he was the first person to kind of twig that it's not just random amounts of stuff that mix together, but that they react in specific ratios, which of course we know from painful titration calculations that we've been doing now for years. But that's what that means, okay? That gases react in ratios of small whole numbers. He basically twigged that. And Avogadro kind of took that ball and ran with it and went a step further. And he said that equal volumes of gas contain equal particles. So equal volumes, equal particles. Again, I'm just sort of writing this very quickly in terms of a mind map. We kind of mentioned this yesterday. Well, yesterday in terms of my video making, which was these balloons, right? Obviously, this could be a completely different day by the time you're reading this, but you get the idea. I don't know why you'd read this. You're listening to this. Nitrogen, oxygen, hydrogen, right? 3 balloons, same volume, same amount of particles. That's what Avogadro's law is. Okay, so now this is where the concept of the mole came from, because we know that a mole of gas is equal to 6 by 10 to the 23 particles. And as we discussed in the previous video, that has a volume of 22.4 litres. So we're introducing the concept of a mole to gases. And again, we can combine this in an equation. And this equation is much more widespread. This is the ideal gas law. And the ideal gas law tells us that PV equals N or T. We're combining Boyle's law. Just get up on that there so you can see it. Boyle's law, Charles's law, and now Avogadro's law as well. R is a concept. It is 8.31. Temperature must be written in Kelvin. Volume is meters cubed, and pressures is pascals. Okay, so it's really important that your units are accurate with these questions. This comes up a lot, and in fact a number of you asked me questions about this, and in the next clip what I'm going to do is I'm actually going to do an example of that question using this equation. Okay, but this equation is very important. It's used a lot. It comes up a lot, and this is what we used. There's an experiment based on this where we worked out the molecular mass of the volatile liquid. Again, that's worth checking out. It's the one where we heated the acetone with the tin foil on it. Do you remember? And we measured it before, measured it afterwards, and we could use this equation to work out how many moles were in the flask. Okay, so very often we rewrite this equation like this. N equals PV over RT, and that means N is the amount of moles. Okay, P is the pressure, V is the volume, T is the temperature. So we basically did this in an experimental setup. We measured the pressure on the day from the atmosphere. We measured the volume of a flask. We measured the temperature of the gas, and we know what the constant is. So in theory, we should be able to calculate the amount of moles of gas that are present. We did that with propanone, with acetone, you might remember at the time. Okay, that's one of your mandatory experiments that sometimes comes up in question 3 on your exam paper. But there you go. That in a nutshell is a little sort of mind map there for gas laws. That's kind of everything you need to know. See, I'm kind of panning back here. I'm getting a bit cocky with these production techniques now. Look at that. That's brilliant. And you can see all that. And what we're going to do now is we're going to practice a question with one of these. All right, hope that helps.